We're going to try and do an example to find the specific heat of. So here's my problem. I've got a metal that probably is put in a beaker of boiling water, so it's currently at 100 degrees. My calorimeter is full of, looks like 125 grams of water, and it's currently 25 degrees Celsius. When I add this hot metal, which was 100 degrees, it's going to lose its heat to the water. So the metal will cool, the water's temperature will rise until eventually they both reach 28.3 degrees Celsius. And from this, we want to figure out what the specific heat of the metal is. Well, to find specific heat, I know I need to use the Q equation. Q equals m times C times delta T. And all of these variables should be for the metal. The mass of the metal was 225 grams. I don't know the specific heat. That's what I'm trying to find. The temperature change of the metal, to find change in temperature, that's always final minus initial. Well, the metal started at 100 degrees. That's the initial temperature. Where did it end? Well, it's going to end at the same temperature that the water did. Heat keeps flowing until they're the same temperature. So the metal ended at 28.3 degrees, just like the water did. So my change in temperature for the metal looks like it's negative 71.7 degrees Celsius. So that goes over here. Change in temperature is negative 71.7 Celsius degrees. All I need now is to find the heat that the metal lost. Unfortunately, I can't find the heat that the metal lost, or they didn't give it to me. But where did the heat that the metal lost go? It went into the water. So I can find the Q of the water very simply by taking the mass of the water, which was 125 grams, times the specific heat of water, 4.184 joules over gram Celsius degree, times the change in temperature of the water. Well, the change in temperature of the water is final minus initial. The water's temperature ended at 28.3 degrees and started at 25, so its change was 3.3 Celsius degrees. That goes right over here, 3.3 Celsius degrees. Notice all my units cancel out except for joules. So when I multiply 125 times 4.184 times 3.3, I get 1725.9 joules of energy that the water absorbed. How does that help me? Well, we've said that the Q of the reaction is equal but opposite the Q of the surroundings. In this case, the reaction is simply the metal, and the surroundings are the water. So the metal is losing heat, the water is gaining heat. So the values are the same. If the water lost 1725 or gained 1725, that means the metal lost 1725. So that would be the same value, just negative. To find C, all we have to do now is simply divide both sides by 225 grams and by the negative 71.7 degrees Celsius. That leaves me with C, or specific heat, of 0.107 joules over gram Celsius degrees. And that would be the answer for the specific heat of the metal. Notice the two negatives cancel out. Specific heat will always have to be a positive value.